Okay. So yesterday we have seen some multi-block dot product and all. So in today's class, we are going to see about CUDA threads with the wide one-dimensional and two-dimensional and multi-dimensional. So how we can define dimension and all. Okay, so already we have seen this particular program. So this vector addition. So adding two matrices. So it's defined as A and B. And here in this particular program, we have given one block and n threads. Okay. So here, some small changes there. So you can define the function as that is kernel function as a global. After that, you can um, uh, you declare here and you can define after that. Okay, so it's not a problem. So here I have written the kernel program below our main function. So here we are using only the thread ID. So what the thread ID will do is it will allocate unique ID for each and every thread for executing the kernel instructions. Okay, executing the same kernel instructions. Okay, so the threads are differentiated with the help of thread ID. Okay, so here we are calling one block with n threads. Okay, so I didn't get the inputs here. Already we have executed this program. Okay, so one dimensional array addition. Okay, can use that same program. Okay, this is the NVIDIA GPU memory hierarchy. So the higher level is called as grid. So grid contains number of SMs. So SMs are nothing but blocks. Okay. So in each and every block contains a number of threads. So the blocks are named as, okay. So in grid, in the sense, we are having some rows and columns. So the blocks are identified as block 00 and block 10, block 20, etc. And the second row and the first column, so block 01, block 11, block 21, likewise it goes on. So the next one is block 02, here 1, 2, after that 2, 3. Okay, likewise it goes on. So here one block is expanded here. Okay, so one block contains so many threads. Okay, so it is named as thread 00, thread 10, thread 20, thread 30, likewise. The naming is some the identity, the otherwise the ID is somewhat similar for block and thread. But block is different and thread is different. So inside grid we are having block, inside block we are having threads. Okay. So already we have discussed this one. The blocks are mapped to the multiprocessors. Otherwise we can say SM, that is streaming multiprocessors. And that is threads mapped to the streaming processor, not the multiprocessors, streaming processor. Stream processor. Otherwise, we can say it as a core. And what threads yesterday we have seen. So it consists of some 32 threads. All the 32 threads are executing simultaneously. Normally, warp threads consist of 32 threads. All the threads executing simultaneously. So again, the next diagram. So it shows both CPU and the GPU. And the host contains our kernel program and the CPU program that will be gone to the grids and the all the grids. Okay, that means how many dimensions we have mentioned or how many blocks we have mentioned. So likewise, it goes on. And here, your blocks may be one dimensional, two dimensional, or three dimensional. Okay, so that has to be represented by the programmers. And also the thread may be 1D, that is one dimensional, or two dimensional, or three dimensional. So here in the above diagram, the 2D blocks are represented. In 2D blocks, it is having rows and columns and all. Okay, and so here in this below diagram, it is having the three-dimensional uh, thread. In the two-dimensional block, it is having three-dimensional thread. Okay, so it is having 4 into 2 into 2 threads. Okay, normally typical configuration is, so per SM it is having 1 to 5 blocks. The streaming multiprocessor, one SM consists of 1 to 5 blocks. That is, one grid consists of 1 to 5 blocks. And each block contains 128 to 1024 threads. Okay, 128 to 1024 threads are there in each block. So, and totally, if you have multiplied, you will be getting around 2K to 100K threads. And so you can launch more number of threads for your kernel instructions. Okay. So, in while considering dimensions while launching the kernel routing, so instead of giving blocks and threads, you can give grid dimension and block dimension. So, if you have mentioned grid dimension, you will be getting more number of threads. Okay, and block dimension, you will be getting some uh, number of threads in that particular block. Here also indirectly it will specify how many number of blocks. It also indirectly specify how many number of threads. Okay. So, but you have to give the grid dimension. Again, grid DIM and block DIM are CUDA variables available in CUDA framework. So, we can say grid is nothing but a collection of blocks, either it is 1D or 2D. And you can use the built-in variable grid sim to specify the size or dimension of the grid. And each copy of the kernel has to be determined. It can determine which block it is executing with the built-in variable block IDX. Okay. So it will be already known with the help of the grid dimension value. Okay, so here blocks are having one dimensional or two dimensional. Okay, and threads are arranged in 1D, 2D, 3D arrays. Okay, so here we are having the built-in variable block dim, and it will specify the size of block. So here within each and every block you are having numerous threads. So thread IDX is used for indexing the threads within the block. Okay, so inside the grid we are having the block IDX. Inside the block dim we are having thread IDX. Okay, so maximum threads per block. So most of the programs it is limited to 512 threads block. Okay, at the maximum. If you need more threads, you can give based on your problem. Okay. So here dimension 3, this is the built-in variables, dim 3, grid dim. So here we'll see how can we represent the two dimensions. So here grid dim dot x, grid dim dot y, both we can use, and grid dim dot z is unused. And block dim, so dimensions, all the three dimensions we can use. Block dim dot x, block dim dot y, block dim dot z. Okay, all the three dimensions we can use. In dim 3 block IDX, Also we are having the x dot y dot z, and also in thread idx. So okay, so we'll move to the next one. So these four are the built-in variables available for the dimensions. Okay. So how we can specify 1D grid and 1D block? Already we know that. Just a recap. So if it is having one dimensional, so what we have to do is block 0, and we are having thread 0, thread 1, thread 2, thread 3. Block 1, thread 0, thread 1, thread 2, thread 3. And block 2 also like that. Okay. So here within each block of threads, thread IDX ranges from 0 to block dimension dot x minus 1. So the each thread has an unique TAD value. And already we know that how we can specify the one dimensional grid. Okay. And here it is not given. For two dimensional, so what you have to given is thread idx dot x plus block dimension dot x into block idx dot x. Okay, this is a formula for using 1D. Okay. For this much number of threads you need. Okay, how we can launch multiple blocks. Okay, so this 65 535 into 512, which is greater than n, and which is greater than 512, because we are restricted to use only 512 threads per block. Okay, so, for example, here they are using 128 threads per block. If you are using some n value, the n value should be in between 512 and this much value. Okay. So, what you have to do is, while specifying, already we have used this in some program, and I have shown the calculation here, 128 threads per block. So, what you have to do is, you have to divide n divided by 128. How many threads are you are going to use in that kernel launching, that should be used for division of the n value. Okay, so here it is. So otherwise actually you can compute like that, n plus 127 divided by 128 blocks. Okay, and because if the n value is less than 128, you would be getting 0. Okay, so at least you have to mention only at least one block. Okay, otherwise it won't be launched properly. It won't be launched because the threads are inside the blocks. Okay, so that's why they have added n plus 127 divided by 128 comma 128. Then the arguments have been passed. Okay, so if you are using 128 threads here, we are dividing it by 128. If you are using 512 threads here, you have to divide it by n value should be divided by 512. Okay, so that is so it is handled here, and thread id is less than n. Already we have seen this one. You have to check this condition, and n is not exactly the multiple of 128. Okay, and okay, again same thing that is repeated again. So see here, dimension 3 n thread 16 comma 2. And dim3 is the CUDA data type with three components having dot x, dot y, and dot z. Each has to be initialized to 1. Okay. So if you have given dimension 3, dim3 means dimension 3. So it will be having three dimension x, dot y, and dot z. Okay. So that has to that will be our default case. It is initialized to 1. And while writing kernel code, how they can, and so in they are here, what it is they are specifying 1D grid and 2D block. We are having one dimensional grid, but we are going to use two dimensional block. So if you are using two dimensional block, we are having dot x and dot y. Okay. So how we can calculate as thread idx dot x. After that, block dimension dot x into thread idx dot y plus block dimension dot x into block dimension dot y into block idx. So this is the formula we have to use while uh, specifying 1D grid and 2D block. Okay. See here. Here one example is given. Dimension 3, dim grid 100 into 50. Okay. So in dimension grid, so we'll be having the blocks 100 into 50, 500 thread blocks are there. So while specifying dimension grid, so there is no need to specify the Z value because the Z is unused. Okay, so you have to specify both X and Y. Okay, so here 5,000 thread blocks are there. So while specifying dimension block, you have to give both X, Y and Z value. Okay, 4 comma 8 comma 8. So you have to while multiplying 4 into 8 into 8, you'll be getting 256 threads per block. This means each block contains 256 thread. Okay. Okay, so sometimes it may AD 65,535, and what you have to do is sometimes it may exceed. Okay, so one dimensional 1D block already we know that, and this also already we knew that. Okay, for one dimensional, so ID is calculated thread IDX dot x plus block IDX into block dimension dot x. Okay, so you can. So already we have discussed some program related to that vector addition. So adding two values a plus b. Okay, so it is called 128, 128. Okay. So here one architecture GTX 480. So here in the GTX 480, minimum number of threads per block is 1024. So it is having 1024 threads per block, and it will be having three dimensions. So in X and Y dimension, we are having 1024 into 1024, and it's a direction, it is having only 64. This is the default value. And each dimension's maximum size of each dimensional grid of thread blocks is 65,535 into 65,535 into 65,535. So this is based on the number of cores available in that particular GPU. Okay. This already you know that you have to specify block comma threads, argument and 1, 2, etc. up to argument 1. This represents block, this represents threads. Okay, let's continue. You know that one block and 100 threads. Okay, so these are all the built-in variables already discussed. Block dimension dot x, block dimension dot y. Already I told you block dimension is z, and so that means the threads in x-axis, y-axis, and z-axis and all. Okay. So you can express your data in collection of blocks or your collection of threads within the block. It's an 1D array, 2D array, or 3D array. Whatever maybe you want, you can represent. Okay. So this is very much useful for. So am I audible? Okay, okay, okay. Thank you. Okay, so it's your choice to either you can represent using 1D array, 2D or 3D array. Based on that, you can represent inside the program. So already we have discussed how we can uh, so identify the exact location. So usually in GPU, the whether your data is 1D or you are representing one dimensional, two dimensional, or three dimensional, so everything is calculated as a serial memory location. Okay, so this one already we have calculated here. The dimension here, number of threads, okay, number of blocks are 4. Okay, it is from 0 to 3. Number of threads in each block is 8. Okay, that is represented 0 to 7. Okay, so we can represent grid dimension as 4 comma 1. Okay, that is 4 into 1. We are having 4 blocks. In grid dimension, we are giving number of blocks. Okay, so we can write it as 4 comma 1. Block dimension, we are representing the threads. Okay, so here how many threads? 8 threads are there in each block. So I can write 8 comma 1. Okay, so if you want to increase the blocks, you can if you are going to use 2 blocks. Okay, in block dimension dot x, you can write 8 comma 2. So if you are using 2 grids, that is sorry. If you are using 2 blocks, you have to represent 4 comma 2. If you are using more threads, so you can write it as 8 comma 2. That means 16 threads you are going to use. Okay, so for getting this value, what you have to do is, it is in third block and each block contains 8 threads plus, so in the index is 2, that is 26. Likewise, you can calculate the exact location of that particular thread. Okay, so we'll move to the next one. So this is again a vector addition. So in the last class, we told you. So here in this particular program, um, so the initialization is not given here. So you write the for loop and get the values of A and B. And you are allocating memory space here and you are doing memcopy. So after that, uh, you know what is the function of seal? What it will do? So if you're having some floating point values like 3.5 something else, so it will be round up to nearest integer. It may be 4. Okay, so it is 3.5 is converted to 4. Okay, so here we need some what integer values. Okay, because we are representing blocks and threads. Okay, so that we have to give the seal. And already in the previous classes I told, because of if this is a floating point operation, you have to convert it here for better. Okay, here the maximum number of threads per dimension in a block is 1024. Okay, so you can use more than one block. Okay, so you can use more than one block. If why you are using more than one block is, you can divide the work between different blocks. Okay, So see here, I'll show one thing, but I couldn't execute. You have calculated the time for execution somewhere in the program. So So if anybody is using Colab, one instruction is if you are not using GPU, that time you stop the this particular runtime from GPU to CPU. Okay, so you can see it here. So it shows me you have to purchase some additional compute units so that I couldn't execute now. If anybody is using Colab, just remain that. Otherwise, they will stop providing coal GPU for you. I'm, I have tried something. Is it? So in the matrix multiplication program, I have calculated the time. That only I am trying to show. See here, the matrix is displayed. It's a bigger matrix. After that, so the execution time is shown here. You can calculate the execution time because this is a C program no. You can easily calculate this is a bigger matrix. So you include some predefined value, CUDA runtime, everything. So you include system sys slash time dot h and CUDA underscore runtime dot h. Okay, both the header files you have to include. After that, you have to use one structure variable struct time val tim. Okay, so use some variable struct time val you use. So you declare that. After that, you include these three statements. Okay, so it will execute time in microseconds. You calculate the time in microseconds. Okay, so the difference in the starting and ending time will be calculated. So for that will be displayed, and this bigger matrix. It is here. So if you want to convert it into our seconds minutes format, that also you can do. And so likewise, you change the dimensions and change it to 1D to 2D, and you calculate time. So which way of programming uh, provides you the better time, that you can take. Okay, so here also you can do that. One I have executed, but it is not rendered due to that limitage issues. Okay. Okay. So here in this case, uh, instead of using single block for a problem, so you can distribute your work among different blocks. Okay. Somehow it saves the time. Okay. You shouldn't overload a single block. Okay. So somewhat you can utilize the GPU. Okay, so already one person asked one question. So how the GPU can be utilized efficiently? So likewise, you can utilize GPU at the same time. You calculate the execution time. Okay, so if the execution time is less, you can choose that number of blocks and that number of threads for your problem. Okay, so here the n value is defined as 1618 and the T is defined as 1024. Okay, so number of threads in each block is defined as 1024. At the maximum, you can give 1024. Okay, that is a better way. And here n is divided by t. So while dividing 1618 divided by 1024, you will be getting some 1.5 something, something like. So that time that is converted into 2. Here 2 blocks and each block is having 1024 threads that is used. Okay, and so that you will be reserving 2 blocks in that particular GPU, and each block is contains how many threads? 1024 threads. Okay, and if anything is error inside this particular kernel launching, the the CUDA framework or CUDA API won't give you any error message. Okay, and so that you have to test this for different values of blocks and thread, and then come to a conclusion. So already we have executed this program too. Then I will move to the next one. So if your data is higher dimensional, that is more than one dimensional, so you go with some higher dimensional data. And already we have seen the variables and all. There are some built-in vector types and structures are available. So those are struct unit 3 x, y, and z. Struct dimensional 3. Uh, that is, it's not unit, it is unsigned integer. So dimension 3 x, y, and z. Okay. So the unsigned structure components are automatically initialized to the value 1. Okay, okay. Why is this breaking up? Nobody is joining. Okay. No. We'll move to the presentation. Okay, so unsigned integer in 3-dimensional. So this is one structure, and struct dimension 3. This is another one structure. So here all components are structure components automatically initialized to 1. Okay. So grid of blocks threads can be defined using these vector types. So other vector types are also available. Okay. So already we have seen this. I'll move to the next one. And the grid dimensions are x and y. Z is not used, already I told. So you can write grid dim dot x. Okay, number of blocks. How can the number of blocks? Already we have calculated grid dim dot x multiplied by grid dim dot y, and block dim. You're having all the dimension x direction, y direction, and z direction. You for calculating the number of threads in the block, you multiply all the 3. So here one more thing, one more example is there. So grid dim 3 grid 16 comma 16, that means 16 into 16 blocks, and dim 3 block 32 comma 32 means 32 into 32 threads. Okay, and so here grid dot x 16 for x direction, it will set 16 blocks, and y direction it will y it is 16, x it is 16, not in the x direction, not in the y direction. Okay, so here block dot x having the value 32, block dot y is having the value 32, block dot z is having the value 1. So here in the block dimension also you can give 3 values. Here x and y values have been given, so defaultly the z value is considered as 1. Okay, so same thing is repeated. Huh? Okay. See, this will represent how the thread IDX, how the block IDX have been shown. Okay. So, well, considering this one, okay, so this is called block idx.x. Already you know that what is the x direction. So this blocked id is dot y, okay, and this particular line is called as block idx dot y into block dimension dot y. Okay, this is y no. Okay, so block idx dot y into block dimension dot y plus thread idx. Okay, and this line is called how it is represented as block idx dot x and block dimension plus thread idx. Okay, so this already we have seen that formula, same one. So in this particular block, we are having threads. Okay, this direction is thread idx. This is called thread idx dot y. Okay, that's all. Okay, so you know that the matrix is represented either row major or column major. So here we are having one two-dimensional matrix. So it is represented as row major. Okay, so you know that. Okay, likewise only the threads are arranged and the blocks are have been arranged. Okay. So usually one more thing is usually the memory is allocated dynamically on GPU. Okay. So because of this dynamic memory allocation, we couldn't uh, use two-dimensional indexes. We can use only one-dimensional index. Okay, here it represents how it is used in C and how it is used in CUDA. Okay, the same thing. So next is two-dimensional matrix addition. I'll paste the program in the chat. So if anybody is interested to execute, you can simply execute this one. Walk to printing, copied and block. Put them and copy after that one line. And copy after that one line from here to here. Okay. So I'll explain the kernel program now. Okay. So in column wise, you have to add that 2D. Okay. So in row wise, you have to add 2D. Okay. So and index is calculated as column plus row multiplied by n. Okay, column plus row into that is multiplied by n. And so after that you have to check the condition. So if a column is less than n and row is less than n, so you have to use this index for adding the two matrices. Okay, so this is a two-dimensional matrix addition. And in kernel program, you simply write this kernel, no problem. And while writing the main program, what you have to do is you have to initialize A and B values. Okay, it is not shown here. You just initialize with the help of two for loop. You get the values for array A and array B. Okay, so after that, the addition happens here. Once all the memory is free, before freeing CUDA memory. So what you have to do is you have to use for loop for printing the value, value, resultant matrix. Okay. Okay, same thing. We have declared three arrays, two-dimensional arrays. So, and three memory, three dynamic memories in GPU for storing array A, array B, and array C. Okay. So the next you have to allocate memory space. Okay, for variable A, variable B, and variable C. So the next is that you have to copy from host to device for A, for B. Okay. So next here block dimension, block dim. That block dim is having the value 5 tol. Okay. So what here dim block, this is actual variable dimension 3 dim block 5 tol comma 5 tol. Okay, that is given. So after that, so the n value is also given as 5 tol. Okay. So all the size, everything is given as 5 tol. So if you want some small values, while for a simulation purpose, you give us some small values here. Okay. So block dim, 5 tol, 5 tol, and dim grid. Okay. So what you have to do? So you have to n has to be divided by some value. Dim block dot x, comma n divided by dim block dot y. Okay. So or directly you can divide. Okay, no problem. And after that, here in this place, by launching the kernel, instead of giving some values, okay, so what you have to do? You have to give dim block, number of blocks, dim grid, that is, sorry, dim grid, that is number of blocks, dim block, number of threads. Okay, so it is calculated here and you can give. So then the variables have been passed. After that, the result is copied from GPU to CPU, and you can paste, print the result, then you can free the memory. Okay, this is a two-dimensional matrix. For two-dimensional matrix, so you will be having some little bit changes. That is for row major, you have to find out the index for row. For column also you have to find out the index. Both the index have been again calculated. After that only you can able to perform the addition operation. Okay. The main reason is in GPU we are allocating memory dynamically. So all the data's values have been stored linearly, whether it is a 1D, 2D, or three-dimensional, or more than three-dimensional. Okay. Anybody is executor? I think the complete program is available in some other document. I think so. Okay, this one. So here I have I didn't a block dimension I have directly given here. So likewise also you can use. I have given 2 comma 3. I didn't given n and all. Okay. So can you able to see my document? Okay, in uh, so first of all, I will explain this one. After that, I'll come back to the comments in the chat. Okay, so here you have to write everything. So after that, so here I what I have given us, I have directly given the row value and column value. So here also I have directly given. So I get the input. Okay, so I will get the input for the second matrix. Okay, so here the space allocation is 2 into 3. We are having 6 values. Either you give 6 in the size of it, otherwise 2 into 3 in the size of it. Whatever maybe you want, you could give. So next, you are copying, that is allocating memory for our variables. So next, copying A and B to device. Okay. So next, again, I am using 3 comma 2. Okay. So directly I have given only the thread block 3 comma 2. In this manner also you can give. Okay, thread block 3 comma 2. Okay. And two-dimensional block structure. So for that the syntax is dim3 thread block. Okay. So and I have given like that. Then the variable, I have given very simple variables. Okay, single character variables. So after that, I am copying everything from GPU to CPU. Then I am printing the matrix, then freeing. Okay, so I got the results like that. So I'll paste this program too. Oh, sorry. I didn't paste all at a single first matrix. Only the first matrix is good. The second matrix I have to copy again. I complete this one. Okay. Okay. It's print. There are some limitations. No two matrices first print. So this program will work. So I execute this one. Have you got the result? So actually, why void double star? Okay, so we are having all the values integer, but the memory allocation is dynamic memory allocation. Okay, and uh, and again we are pointing to the pointer. That's why we are giving void double star. Okay, so all the CUDA variable have to be so. See, if you have in the first and second classes, we have given some immediate values. Okay, if you have given some assigning some values a equal to 5, b equal to 7, that time simple calculations. There is no need to give like int star a, int star b, everything in the kernel program itself. Okay, you can give a, b like that. Okay, so if you are getting values from the user, so that time you have to specify it as a pointer variable because we are allocating memory dynamically. So that we have to give one like that only. Okay, so all the most of the variables in GPU should be a pointer. Okay, so and one more program, and here in this particular program, so what you can do is you can access the dimensions. Okay, so here the simple program. Okay, dimension 3 grid 2, 3, 4, that is given. Dimension 3 block 5, 6, 7, that is given. Okay, so it is assigned to grid or block. And in the kernel program, um, what you can do is there is nothing is passed here. Okay, so you are not calculating anything, so there is no need to pass anything. And the kernel is launched with a grid comma block. Okay, so sorry, here in this program, this thread synchronize is depreciated, so you have to give device synchronize. I got to change. So CUDA device synchronize. Already we have used CUDA device synchronize. So you can use it. And so here in kernel, if thread idx dot x equal to 0 ampersand and block idx dot x equal to 0. So if all those things is 0, then we are asking to print everything. Okay, that's all. Okay, very simple program. Either you can give some values and asking to print what is the grid dimension dot x, grid dimension dot y, grid dimension dot z, and block dimension x, y, z values. Okay, so you can see here the number of the grid means it specifies the number of blocks. Okay, so number of blocks in the grid is 2 into 3 into 4. Okay, number of threads in a block is 5 into 6 into 7. Okay. Number of threads in a block is 5 into 6 into 7. Number of blocks, that is, I can say thread blocks. So number of blocks in the grid is 2 into 3 into 4. Okay. Then what about the number of threads launched? Okay. We are having 24, 24 blocks. Okay. And each 210 threads per block. Okay, you have to multiply 210 into 24. You'll be getting number of threads learned totally. Okay, so this will represent that one. And I'll paste the code. Whether it it will run or not, I don't know. 38x.x invalid syntax. It won't come invalid syntax. So already this program I have executed program. Now only I'm not executing due to the problem in my Colab. Sometimes this matrix add index equal to 38x.x int 80. Okay, all the variables are integer variables only. That is not a problem. So anyone got correct answer for that program I have pasted the chat box? This other program. It is not copied. Okay, Padma madam will discuss later in offline for your error. Okay, any other doubt? Okay, so today we have discussed some three dimensions and how can we write programs using more than one dimension. So in GPU, okay. So thank you again. Okay, we'll see you tomorrow. Thank you.